In continuing the steps on how to graph rational functions, we're going to take a look at intercepts, both x and y. I pause the video and make these corrections. So the x-intercepts, you need to factor and set the numerator equal to 0 after establishing the domain. Very important. For the y-intercept, you're going to set x is equal to 0. So let's take a look at how to do that. So let's go ahead and factor. So we're going to factor out the 2, and then here we're going to make it multiply to negative 54 and add to 15. What two numbers do that? You can use a calculator to find those numbers, but I like to do it this way just so I can know what numbers I've tried and what I haven't. All right, 1 times 54, 2 times 27. If I know 2, I know 4, I know 8. 3 times 18, and that might be what I'm looking for. So 3 and 18. I need the 3 to be negative because I needed to add 15. All right, divided by a, which is 2. So that simplifies negative 9, and that just stays the same. So let's write this out. When you write this out, you take the 2 in front of the x, plus 3, and then this is just x minus 9. All right, now that I have factored it out, I need to establish the domain. How do I establish the domain? No, we can't divide by 0, so that denominator, none of that can equal 0. So the domain exists such that that's not equal to 0. So take negative to the other side and then divide by 2, so that's 3 over 2. Take 9 to the other side, becomes negative 9. So I cannot have 3 over 2 or x minus 9 in order for this to work. So none of the denominator can be equal to 0. All right, so now let's set the numerator equal to 0 to see what it is. So divide by 2, take 9 to the other side, so it's negative 9. Negative 9 already exists, so here there is no x-intercepts because x cannot be equal to negative 9 because it's going to make the denominator 0. All right, let's go ahead and do another question. All right, so again, first factor, so let's make it multiply to negative 12, add to positive 4. What two numbers do that? 6 and 2 make the 2 negative. Okay, that's going to work. All right, so it's going to be x plus 2, x minus 2 over, we can take out 3x, so factor the greatest common factor, leaving x minus 2. To factoring, let's establish a domain. So remember, the denominator cannot equal 0. What does that mean? 3x cannot equal 0. And x minus 2 cannot equal 0. So that means x cannot equal to 0, and x cannot equal to 2 because you take 2 to the side. All right, so as long as those two things don't happen, then you have an x-intercept. All right, so let's go ahead and set the numerator equal to 0. So we have x plus 6 times x minus 2 equals 0. And solving one at a time, take the negative 6 to the other side, it's going to be negative 6. Take the negative 2 to the other side, it's going to be positive 2. All right, so we cannot have x equals 2 because that's going to make it 0, but the x minus 6 is perfect. Write it in coordinate form, so it's negative 6 comma 0. All right, let's look at another example. So again, we start off by factoring. So this is a really big number. 3 goes into every single one of those, so we can make this number smaller. We're going to factor out 3, so that leaves x squared minus 45 divided by 3 is 15. 150 divided by 3 is 50. And on the bottom, we can factor out x, so we're going to have x minus 6. All right, now that we have that, now let's go ahead and factor. So it multiplies to 50 and adds to 15. So what numbers do that? 5 and 10. And we need both of them to be negative, so it can be positive when you multiply, and negative 15. That works. Okay, so let's go ahead and write that out. So the numerator is going to become 3x minus 5 and x minus 10 over x minus 6. Okay, now that we're there, establish a domain. Okay, so always establish a domain before. That means x cannot be equal to 0 and x minus 6 cannot be equal to 0. So x cannot be equal to 0. X minus 6, solving for x, is going to be plus 6 when you take it to the other side. So x cannot equal 0, x cannot equal 6 because that makes the denominator 0, which cannot divide by 0. All right, once you've done that, take the numerator and set that equal to 0. So dividing both sides by 3, just going to be left with the parentheses. Then set each of those equal to 0. So take minus 5 to the side, positive 5. Take negative 10 to the other side, positive 10. And then let's look at my domain restrictions. So those are both good. So write them out in terms of coordinates. And those are your coordinates for your x-intercepts. All right, pause the video and try now example 10. We're going to take a look at y-intercepts. It's a lot more simpler. So all we're doing is setting x equal to 0. Everywhere I see an x, I'm going to put a 0 in its place. So 5, I see an x, 0 plus 7. And then go ahead and solve it. So I'm just going to be left with negative 4 over 7. So my y-intercept in coordinate form is going to be 0 for the x variable and negative 4 over 7. Okay, there is a shortcut to this. Notice all the x's are going to have 0. So anything with x is just going to disappear. So really the answer is only going to be whatever doesn't have x on the top over whatever doesn't have x on the bottom. All right, so I'm going to ask you to do example 12. Remember, all the x's go to 0. So what would be the y-intercept for this problem in coordinates? Let's practice.